This presentation is about compounds and atoms, and it's section 3.2 in our chemistry section. Dalton's atomic theory. John Dalton was a teacher who liked to study science. And one of the things he did is he came up with some of the first symbols. When you look at these symbols, you'll see one for silver, one for lead, carbon, which are all on our periodic table. But you'll also see some symbols for compounds, such as soda and lime. Lime is actually calcium oxide. So he had a beginning to the idea of atoms, and then he was using these symbols as well for compounds, but perhaps unbeknownst to him, he didn't know they were compounds. Dalton's atomic theory has 5 points. The first thing that he thought was that all elements are made of tiny particles called atoms. We know that this is true today. His second point, atoms of a given element are identical. Now, just recently, you've been writing formulas for isotopes, and this is not true. You can have hydrogen with 1 proton and 0 neutrons. So its nuclear symbol would look like that. We also have hydrogen that has 1 proton and 1 neutron. So its mass number is 2. So John Dalton did not know about isotopes, but this was a beginning in the 1800s of trying to classify the matter around us. The third point is that atoms of a given element are different from those of any other element, and we know this to be true today. If we say this red atom is oxygen, we now know that oxygen has 8 protons in it, and let's say this atom is hydrogen, and how many protons are in hydrogen? You look on your periodic table, or perhaps you just know it has 1. So this is a true statement to this day. He also determined that atoms of one element can combine with atoms of other elements to form compounds. So this is true. This compound has a hydrogen with oxygen, and so we know this to be H2O. We also know that a given compound always has the same relative numbers and types of atoms. So if we look at that H2O again, whenever you have 2 hydrogen atoms to 1 oxygen atom, you know that that is water. So I'm going to write this oxygen so you don't think it's 10. And let's rewrite this guy and write 2 hydrogen. And these are 2 hydrogen atoms to 1 oxygen atom. And this is true to this day. Our last point is that atoms are not created or destroyed in a chemical reaction. They're just rearranged. So you could add to your notes, just rearranged. So if we took water, H2O, and you add electricity, so this is just a 9-volt battery, notice this top part is a gas. So you fill these test tubes with water, and as the water decomposes, it fills with gas. The gas on this side, you have lots of little atoms. This is oxygen. And this side is hydrogen. Now, how do I know that the part I outlined in red is hydrogen? Notice it's about twice as much gas. Remember, our ratio was 2 hydrogen atoms to every 1 oxygen atom. And with gases, if they're at the same temperature and pressure, you can compare them completely.